analysis. I was thinking in vague images, and it was just something non-conceptual. And then it took me a long, long time to pull it
These
out
guys are
into
bullshitters,
concepts,
man.
and then longer to put it into math. But the real insights didn't
To
come
make
from
up the
just
false math,
slavishly,
you mean?
playing with equations.
Yeah.
They came from a deeper place.
Mm-hmm.
And so there may be this going back and forth between the complete non-conceptual, where there's essentially no end to the wisdom, and then conceptual systems where there's the Gödel limits that we have to that. And that may be, if consciousness is important and fundamental, that may be what consciousness, at least part of what consciousness is about, is this discovering itself, discovering its possibilities, so to speak. We can talk about what that might mean. By going from the non-conceptual to the conceptual and back and forth.
To get better and better and better at being.
Right.
Let me ask you, just to linger on the evolutionary, because you mentioned evolutionary game theory, and that's really where the perspective from which you come to form the case against reality. At which point in our evolutionary history do we start to deviate the most from reality? Is it way before life even originated on Earth? Is it in the early development for bacteria and so on? Or is it when some inklings of what we think of as intelligence, or maybe even complex consciousness, started to emerge? So where did this deviation, just like with the interfaces in a computer, you start with transistors, and then you have assembly, and then you have C, C++, and you have Python, and then you have GUIs, all that kind of, you have layers upon layers. When do we start to deviate?
Well, David Marr, again, my advisor at MIT, in his book Vision, suggested that the more primitive sensory systems were less realistic, less veridical. But that by the time you got to something as complicated as the humans, we were actually estimating the true shapes and distances to objects and so forth. So his point of view, and I think it was probably, it is not an uncommon view among my colleagues, that yeah, the sensory systems of lower creatures may just not be complicated enough to give them much truth. But as you get to 86 billion neurons, you can now compute the truth, or at least the parts of the truth that we need. When I look at evolutionary game theory, one of my graduate students, Justin Mark, did some simulations using genetic algorithms. So there he was just exploring, we start off with random organisms, with random sensory genetics and random actions, and the first generation was unbelievably, it was a foraging situation. They were foraging for resources, and most of them just stayed in one place, didn't do anything important, but we could then just look at how the genes evolved, and what we found was, what he found was that basically you never even saw the truth organisms even come on the stage. They if they came up, they were gone in one generation. They just weren't. So they came and gone. They came and went, even just in one generation. They just are not good enough. The ones that were just tracking, their senses just were tracking the fitness payoffs, were far more fit than the truth seekers. So an answer at one level, I want to give an answer at a deeper level, but just with evolutionary game theory. Because my attitude as a scientist is, I don't believe any of our theories. I take them very, very seriously. I study them. I look at their implications, but none of them are the gospel. They're just the latest ideas that we have. And so the reason I study evolutionary game theory is because that's the best tool we have right now in this area. There is nothing else that competes. And so as a scientist, it's my responsibility to take the best tools and see what they mean. And the same thing the physicists are doing. They're taking the best tools and looking at what they entail. But I think that science now has enough experience to realize that we should not believe our theories in the sense that we've now arrived. In 1890, it was a lot of physicists thought we'd arrived. They were discouraging bright young students from going into physics because it was all done. And that's precisely the wrong attitude.
Yep.
Forever. It's the wrong attitude forever. The attitude we should have is a century from now, they'll be looking at us and laughing at what we didn't know. And we just have to assume that that's going to be the case. Just know that everything that we think is so brilliant right now, our final theory, a century from now, they'll look at us like we look at the physicists of 1890 and go, how could they have been so dumb?
Yeah.
So I don't want to make that mistake. So I'm not doctrinaire about any of our current scientific theories. I am doctrinaire about this. We should use the best tools we have right now.
Mm-hmm.
That's
and
what we've got.
with humility. Well, so let me ask you about game theory. There's, I love game theory, evolutionary game theory, but I'm always suspicious of it, like economics. When you construct models, it's too easy to construct things that oversimplify just because our human brains enjoy the simplification of constructing a few variables that somehow represent organisms or represent people and running a simulation that then allows you to build up intuition, and then it feels really good because you can get some really deep and surprising intuitions. But how do you know your models aren't, the assumptions underlying your models aren't some fundamentally flawed, and because of that your conclusions are fundamentally flawed? So I guess
Yes.
my question is, what are the limits in your use of game theory, evolution game theory, your experience with it? What are the limits of game theory?
So I've gotten some pushback from professional colleagues and friends who have tried to rerun simulations and the idea that we don't see the truth is not comfortable. And so many of my colleagues are very interested in trying to show that we're wrong. And so the idea would be to say that somehow we did something, as you're suggesting, maybe something special that wasn't completely general. We've got some little special part of the whole search space in evolutionary game theory in which this happens to be true, but more generally, organisms would evolve to see the truth. So the best pushback we've gotten is from a team at Yale, and they suggested that if you use thousands of payoff functions, so we in our simulations we just use a couple, one or two, because it was our first simulations, right? So that would be a limit. We had one or two payoff functions. We showed the result in those, at least for the genetic algorithms. And they said if you have 20,000 of them, then we can find these conditions in which truth-seeing organisms would be the ones that evolved and survived. And so we looked at their simulations, and it certainly is the case that you can find special cases in which truth can evolve. So when I say it's probability zero, it doesn't mean it can't happen. It can happen. In fact, it could happen infinitely often. It's just probability zero. So probability zero things can happen infinitely often.
When you say probability zero, you mean probability close to zero?
To be very, very precise. So for example, if I have a unit square on the plane, and I use a measure in which on a probability measure in which the area of a region is this probability.
Mm-hmm.
Then if I draw a curve in that unit square, it has measured precisely zero. Precisely, not approximately, precisely zero. And yet it has infinitely many points. So there's an object that, for that probability measure, has probability zero, and yet there's infinitely many points in it. So that's what I mean when I say that the things that are probability zero can happen infinitely often, in principle.
Yeah, but infinity, as far as and I look outside often, I walk around and I look at people, I have never seen infinity in real life.
That's an interesting issue.
I've been looking. I don't notice it. Infinitely small or the infinitely big. And so the tools of mathematics, you could sort of apply the same kind of criticism that it is a very convenient interface into our reality.
That's a big debate in mathematics, the intuitionists versus the ones who take, for example, the real numbers as real. And that's a fun discussion. Nicholas Geeson a physicist, had really interesting work recently on how if you go with intuitionist mathematics, you could effectively quantize Newton, and you find that Newtonian theory and quantum theory aren't that different once you go with
It's funny.
It's really quite interesting. So,
Yeah.
so the issue you raise is a very, very deep one, and one that I think we should take quite seriously, which is, how should we think about the reality of, Contour's hierarchy, A left 1, A left 2, and all these different infinities, versus just a more algorithmic approach, right? So where everything's computable in some sense, and everything's finite, as big as you want, but nevertheless finite.
So yeah, ultimately boils down to whether the world is discrete or continuous in some general sense. And again, we can't really know, but there's just a mind-breaking thought, just common sense reasoning, that something can happen and is yet probability of it happening is 0%. That doesn't compute for common sense computer.
Right. This is where you have to be a sharp mathematician to really, and I'm not.
Sharp is one word. Sure. What I'm saying is common sense computer is, I mean that in a very kind of, in a positive sense, because we've been talking about perception systems and interfaces. If we are to reason about the world, we have to use the best interfaces we got. And I'm not exactly sure that game theory is the best interface we got for this.
Oh, right.
And application of mathematics, tricks and tools of mathematics to game theory is the best we got when we are thinking about the nature of reality and fitness functions and evolution, period.
Well, that's a fair rejoinder, and I think that that was the tool that we used. And if someone says, here's a better mathematical tool, and here's why, this mathematical tool better captures the essence of Darwin's idea. John Maynard Smith didn't quite get it with evolutionary game theory. There's this thing. Now, there are tools like evolutionary graph theory, which generalize evolutionary game theory. And then there's quantum game theory. So you can use quantum tools like entanglement, for example, as a resource in games that change the very nature of the solutions, of the optimal solutions of the game theory.
Well, the work from Yale is really interesting. It's a really interesting challenge of that kind of these ideas where, okay, if you have a very large number of fitness functions, or let's say you have a nearly infinite number of fitness functions or a growing number of fitness functions, what kind of interesting things start to emerging. If you are to be an organism, if to be an organism that adapts means having to deal with an ensemble of fitness functions.
Right, and so we've actually redone some of our own work based on theirs, and this is the back and forth that we expect in science, right? And what we found was that in their simulations, they were assuming that you couldn't carve the world up into objects. And so we said, well, let's relax that assumption. Allow organisms to create data structures that we might call objects. And an object would be you would do hierarchical clustering of your fitness payoff functions, the ones that have similar shapes. If you have 20,000 of them, maybe these 50 are all very, very similar. So I can take all the perception, action, fitness stuff and make that into a data structure, and we'll call that a unit or an object. And as soon as we did that, then all of their results went away. It turned out they were the special case, and that the organisms that were allowed to only see, that were shaped to see only fitness payoffs were the ones that were. So the idea is that objects then, what are objects from an evolutionary point of view? This bottle, we thought that when I saw a bottle, it was because I was seeing a true object that existed whether or not it was perceived. Evolutionary theory suggests a different interpretation. I'm seeing a data structure that is encoding a convenient way of looking at various fitness payoffs. I can use this for drinking.
Mm-hmm.
I could use it as a weapon, not a very good one. I could beat someone over the head with it.
Yeah.
If my goal is mating, this is pointless.
Mm-hmm.
So I'm seeing what I'm coding here is all sorts of actions and the payoffs that I could get. When I pick up an apple, now I'm getting a different set of actions and payoffs. When I pick up a rock, I'm getting, so for every object, what I'm getting is a different set of payoff functions and act with various actions. And so once you allow that, then what you find is once again, that truth goes extinct, and the organisms that just get an interface are the ones that win.
But the question, just sneaking up on this, is fascinating. From where do fitness functions originate? What gives birth to the fitness functions? So, if there's a giant black box that just keeps giving you fitness functions, what are we trying to optimize? You said that water has different uses than an apple, so there's these objects. What are we trying to optimize? And why is not reality a really good generator of fitness functions?
So each theory makes its own assumptions and says, grant me this, and I'll explain that. So evolutionary game theory says, grant me fitness payoffs, right? And grant me strategies with payoffs, and I can write down the matrix for this strategy interacts with that strategy. These are the payoffs that come up. If you grant me that, then I can start to explain a lot of things. Now you can ask for a deeper question, like, okay, so how does physics evolve biology, and where do these fitness payoffs come from, right? Now, that would be that's a completely different enterprise, and of course, evolutionary game theory then would be not the right tool for that. It would have to be a deeper tool that shows where evolutionary game theory comes from. My own take is that there's going to be a problem in doing that because space-time isn't fundamental. It's just a user interface. And that the distinction that we make between living and non-living is not a fundamental distinction. It's an artifact of the limits of our interface. Right, so this is a new wrinkle, and this is an important wrinkle. It's so nice to take space and time as fundamental, because if something looks like it's inanimate, it's inanimate, and we can just say it's not living. Now, it's much more complicated. Certain things are obviously living. I'm talking with you. I'm obviously interacting with something that's alive and conscious.
I think we've let go of the word obviously in this conversation. I think nothing is obvious.
That's obvious, that's right. But when we get down to like an ant, it's obviously living, but I'll say it appears to be living. Yeah. But when we get down to a virus, now people wonder, and when we get down to protons, people say it's not living. And my attitude is, look, I have a user interface. The interface is there to hide certain aspects of reality, and others to it's an uneven representation, put it that way. Certain things just get completely hidden. Dark matter and dark energy are most of the energy and matter that's out there. Our interface just plain flat out hides them. Mm-hmm. The only way we get some hint is because gravitational things are going wrong within our. So most things are outside of our interface. The distinction between living and non-living is not fundamental. It's an artifact of our interface. If we really want to understand where evolution comes from, to answer the deep question you asked, I think the right way we're going to have to do that is to come up with a deeper theory than space-time, in which there may not be the notion of time, and show that whatever the dynamics of that deeper theory is. And by the way, I'll talk about how you could have dynamics without time, but the dynamics of this deeper theory, when we project it into in certain ways, then we do get space-time, and we get what appears to be evolution by natural selection. So I would love to see evolution by natural selection, nature red in tooth and claw, people fighting, animals fighting for resources and the whole bit, come out of a deeper theory in which perhaps it's all cooperation. There's no limited resources and so forth, but as a result of projection, you get space and time, and as a result of projection, you get nature red in tooth and claw, the appearance of it. But it's all an artifact of the interface.
I like this idea that the line between living and non-living is very important, because that's the thing that would emerge before you have evolution, the idea of death. So that seems to be an important component of natural selection. If that emerged, because that's also asking the question, I guess, that I ask, where do fitness functions come from? That's like asking the old meaning of life question, right? Is what's the why? Why? And one of the big underlying whys, okay, you can start with evolution on Earth, But without living, without life and death, without the line between the living and the dead, you don't have evolution. So what if underneath it, there's no such thing as the living and the dead? There's no, like this concept of an organism, period. There's a living organism that's defined by a volume in space-time.
Oh, is that right?
That somehow interacts.
Is that right, Lex?
That over time maintains its integrity somehow. It has some kind of history. It has a wall of some kind. The outside world, the environment, and then inside there's an organism.
Oh,
so you're defining an organism,
sure.
And also you define that organism by the fact that it can move.
Oh, is that right?
And it can come alive,
wow.
Which you kind of think of as moving.
Wow.
Combined with the fact that it's keeping itself separate from the environment, so you can point out that thing is living, and then it can also die. That seems to be
maybe you should know about the Metellus.
Powerful
Nanolith
components
Metellus.
of space-time that enable you to have something like natural selection.
Yeah, that's what you should
and
know
evolution.
about.
Well, and there's a lot of interesting work, some of it by collaborators of Carl Friston and others, where they have Bayes-net kind of stuff that they build on, and the notion of a Markov blanket. So you have some states within this network that are inside the blanket, then you have the blanket, and then the states outside the blanket. And the states inside this Markov blanket are conditionally independent of the states outside the blanket, conditioned on the blanket. And what they're looking at is that the dynamics inside of the states inside the Markov blanket seem to be trying to estimate properties of the outside and react to them in a way. So it seems like you're doing probabilistic inferences in ways that might be able to keep you alive. So there's interesting work going on in that direction. But what I'm saying is something slightly different, and that is, like when I look at you, all I see is skin, hair, and eyes, right? That's all I see.
Mm-hmm.
But I know that there's a deeper reality. I believe that there's a much deeper reality. There's the whole world of your experiences, your thoughts, your hopes, your dreams. In some sense, the face that I see is just a symbol that I create, right? And as soon as I look away, I delete that symbol. But I don't delete you. I don't delete the conscious experience, the whole world of your. So I'm only deleting an interface symbol. But that interface symbol is a portal, so to speak. Not a perfect portal, but a genuine portal into your beliefs, into your conscious experiences, that's why we can have a conversation. We genuinely, your consciousness is genuinely affecting mine is genuinely affecting yours through these icons, which I create on the fly. I create your face when I look, I delete it. I don't create your consciousness, that's there all the time. But I do. So now when I look at a cat, I'm creating something that I still call living, and I still think is conscious. When I look at an ant, I create something that I still would call living, but maybe not conscious. When I look at something I call a virus, now I'm not even sure I would call it living. And when I look at a proton, I would say I don't even think it's not alive at all. It could be that I'm nevertheless interacting with something that's just as conscious as you. I'm not saying the proton is conscious. The face that I'm creating when I look at you, that face is not conscious. That face is a data structure in me. That face it's an experience, it's not an experiencer. Similarly, a proton is something that I create, when I look, or do a collision in the Large Hadron Collider or something like that. But what is behind the entity in space-time? So I've got this space-time interface, and I've just got this entity that I call a proton. What is the reality behind it? Well, the physicists are finding these big structures, the amplituhedron, the sociohedron. What's behind those? Could be consciousness, what I'm playing with. In which case, when I'm interacting with a proton, I could be interacting with consciousness. Again, to be very, very clear, because it's easy to understand, I'm not saying a proton is conscious. Just like I'm not saying your face is conscious. Your face is a symbol I create and then delete as I look in. So your face is not conscious, but I know that face in my interface, the Lex Friedman face that I create, is an interface symbol that's a genuine portal into your consciousness. The portal is less clear for a cat, even less clear for an ant, and by the time we get down to a proton, the portal is not clear at all. But that doesn't mean I'm not interacting with consciousness. It just means my interface gave up. and there's some deeper reality that we have to go after. So your question really forces out a big part of this whole approach that I'm talking about.
So it's this portal and consciousness. I wonder why you can't. Your portal is not as good to a cat, to the cat's consciousness, than it is to a human. Does it have to do with the fact that you're human, and just similar organisms of similar complexity are able to create portals better to each other, or is it just as you get more and more complex, you get better and better portals?
Well, let me answer one aspect
Yes.
of it that I'm more confident about, and then I'll speculate on that. Why is it that the portal is so bad with protons? Well, and elementary particles more generally, so quarks, leptons, and gluons, and so forth. Well, the reason for that is because those are just symmetries of space-time. More technically, they're irreducible representations of the Poincare group of space-time. So they're just literally representations of the data structure of space-time that we're using. So that's why they're not very much insightful. They're just almost entirely tied to the data structure itself. There's not much. They're telling you only something about the data structure, not behind the data structure. It's only when we get to higher levels that we're starting to, in some sense, build portals to what's behind space-time.
Sure. Yeah. So there's more and more complexity built on top of the interface of space-time with the cat.
So you can actually build a portal, right?
Yeah. Although, yeah, right. Yeah, this interface of face and hair and so on, skin. There's some syncing going on between humans, though, where we sync like you're getting a pretty good representation of the ideas in my head, and starting to get a foggy view of my memories in my head. Even though, this is the first time we're talking, you start to project your own memories. You start to solve like a giant hierarchy of puzzles about a human. Because we're all, there's a lot of similarities, a lot of it rhymes. So you start to make a lot of inferences, and you build up this model of a person. You have a pretty sophisticated model of what's going on underneath. Again, I wonder if it's possible to construct these models about each other and nevertheless be very distant from an underlying reality.
Yes, there's a lot of work on this. So there's some interesting work called signaling games, where they look at how people can coordinate and come to communicate. There's some interesting work that was done by some colleagues and friends of mine, Louis Narens, Natalia Komarova, and Kimberly Jameson, where they were looking at evolving color words. So you have a circle of colors, this is the color circle, and they wanted to see if they could get people to cooperate and how they carved the color circle up into units of words. And so they had a game theoretic kind of thing that they'd had people do. And what they found was that when they included, most people are trichromats, 3 kinds of cone photoreceptors, but there are a lot of men, 7% of men are dichromats. They might be missing the red cone photoreceptor. They found that the dichromats had an outsized influence on the final ways that the whole space of colors was carved up and labels attached. You needed to be able to include the dichromats in the conversation, and so they had a bigger influence on how you made the boundaries of the language. And I thought that was a really interesting kind of insight, that there's going to be, again, perhaps a game or evolutionary or genetic algorithm kind of thing that goes on in terms of learning to communicate in ways that are useful. And so, yeah, you can use game theory to actually explore that, or signaling games. There's a lot of brilliant work on that. I'm not doing it, but there's work out there.
So if it's okay, let us tackle once more, and perhaps several more times after, the big topic of consciousness.
Okay.
This very beautiful, powerful things that perhaps is the thing that makes us human. What is it? What's the role of consciousness in, let's say, even just the thing we've been talking about, which is the formation of this interface? Any kind of ways you want to kind of start
Sure.
talking about it.
Well, let me say first what most of my colleagues say. 99% are, again, assuming that space-time is fundamental, particles in space-time, matter is fundamental, and most are reductionist. And so the standard approach to consciousness is to figure out what complicated systems of matter with the right functional properties could possibly lead to the emergence of consciousness. That's the general idea, right? So maybe you have to have neurons. Maybe only if you have neurons, but that might not be enough. They have to have certain kinds of complexity in their organization and their dynamics, certain kind of network abilities, for example. So there are those who say, for example, that consciousness arises from orchestrated collapse of quantum states of microtubules in neurons. So this is the Hemlock universe. That's kind of. So you start with something physical, a property of quantum states of neurons, of microtubules and neurons, and you say that somehow an orchestrated collapse of those is consciousness or conscious experiences. Or integrated information theory. Again, you start with something physical, and if it has the right kind of functional properties, something they call phi, with the right kind of integrated information, then you have consciousness. Or you can be a panpsychist, Volkov, for example, where you might say, well, in addition to the particles in space and time, those particles are not just matter, they also could have, say, a unit of consciousness. And so, but once again, you're taking space and time and particles as fundamental, and you're adding a new property to them, say, consciousness. And then you have to talk about how when a proton and neutron, or a proton and electron get together to form hydrogen, and how those consciousnesses merge to or interact to create the consciousness of hydrogen and so forth. There's attention schema theory, which again is how neural network processes representing to the network itself its attentional processes. That could be consciousness. There's global workspace theory, a neuronal global workspace theory. So there's many theories of this type. What's common to all of them is they assume that space-time is fundamental. They assume that the physical processes in space-time is fundamental. Panpsychism adds consciousness as an additional thing. It's almost dualist in that regard. And the idea is, our best science is telling us that space-time is not fundamental. So, why is that important? Well, for centuries, deep thinkers thought of earth, air, fire, and water as the fundamental elements. It was a reductionist kind of idea. Nothing was more elemental than those, and you could sort of build everything up from those. When we got the periodic table of elements, we realized that, of course, we want to study earth, air, fire, and water. There's combustion science for fire. There's sciences for all these other things, water and so forth. So we're going to do science for these things, but fundamental? No. If you're looking for something fundamental, those are the wrong building blocks. Earth has many different kinds of elements that project into the one thing that we call Earth. If you don't understand that there's silicon, that there's iron, that there's all these different kinds of things that project into what we call table, then we came up with quarks, leptons, and gluons, the particles of the standard model of physics. And so we actually now know that if you really want to get fundamental, the periodic table is a net. It's good for chemistry, and it's just wonderful for chemistry, but if you're trying to go deep fundamental, what is the fundamental science? That's not it. You're going to have to go to quarks, leptons, and gluons and so forth. Well, now we've discovered space-time itself is doomed. Quarks, leptons, and gluons are just irreducible representations of the symmetries of space-time. So the whole framework on which consciousness research is being based right now is doomed. And for me, these are my friends and colleagues that are doing this. They're brilliant. They're brilliant. My feeling is, I'm so sad that they're stuck with this old framework, because if they weren't stuck like with earth, air, fire, and water, you could actually make progress. I mean, so it doesn't matter how smart you are. If you start with earth, air, fire, and water, you're not going to get anywhere, right?
Can I actually just, because the word doom is so interesting. Let me give you some options, multiple choice quiz. Is space-time, say, is reality the way we perceive it doomed, wrong, or fake? Because doomed just means it could still be right, and we're now ready to go deeper.
It would be that.
So it's not wrong. It's not a complete deviation from a journey toward the truth.
Right. It's like earth, air, fire, and water is not wrong. There is earth, air, fire, and water, and that's a useful framework, but it's not fundamental.
Right. Well, there's also wrong, which is they used to believe, as I recently learned, that George Washington was the first president of the United States, was bled to death for something that could have been easily treated. Because it was believed that you can get, actually I need to look into this further, but I guess you get toxins out or demons out. I don't know what you're getting out of the bleeding of a person. But so that ended up being wrong, but widely believed as a medical tool. So it's also possible that our assumption of space-time is not just doomed, but is wrong.
Well, if we believe that it's fundamental, that's wrong. But if we believe it's a useful tool, that's right.
But it could see, but bleeding somebody to death was believed to be a useful tool.
That's wrong.
It wasn't just not fundamental. It was very. I'm sure there's cases in which bleeding somebody would work, but it would be a very tiny, tiny, tiny percentage of cases. So it could be that it's wrong. Like it's a side road that's ultimately leading to a dead end, as opposed to a truck stop or something that you can get off of.
My feeling is it's not a dead end kind of thing. I think that what the physicists are finding is that there are these structures beyond space-time, but they project back into space-time. And so space-time, when they say space-time is doomed, they're explicit. They're saying it's doomed in the sense that we thought it was fundamental. It's not fundamental. It's a useful, absolutely useful and brilliant data structure. But there are deeper data structures, like cosmological politics. And space-time is not fundamental. What is doomed, in the sense that it's wrong, is reductionism.
Which is saying space-time is fundamental.
Right. The idea that somehow being smaller in space and time, or space-time, is a fundamental nature of reality. That's just wrong. It turned out to be a useful heuristic for thermodynamics and so forth, and in several other places that reductionism has been very useful. But that's, in some sense, an artifact of how we use our interface.
Yeah, so you're saying size doesn't matter. Okay, this is very important for me to write down. Ultimately.
Right. I mean, it's useful for theories like thermodynamics, and also for understanding brain networks in terms of individual neurons, and neurons in terms of chemical systems inside cells. That's all very, very useful. But the idea that we're getting to the more fundamental nature of reality, no. When you get all the way down in that direction, you get down to the quarks and gluons, what you realize is what you've gotten down to is not fundamental reality, just the irreducible representations of a data structure. That's all you've gotten down to. So you're always stuck inside the data structure. So you seem to be getting closer and closer. I went from neural networks to neurons to chemistry to particles to quarks and gluons. I'm getting closer and closer to I'm getting closer and closer to the actual structure of the data structure of space and time, the irreducible representations of it. That's what you're getting closer to, not to a deeper understanding of what's beyond space and time.
We'll return again to this question of dynamics, because you keep saying that space-time is doomed, but mostly focusing on the space part of that. It's very interesting to see why time gets the bad cred too, because how do you have dynamics without time is the thing I'd love to talk to you a little bit about. But let us return your brilliant whirlwind overview of the different theories of consciousness that are out there. What is consciousness outside of space-time?
if we think that we want to have a model of consciousness, we, as scientists, then have to say, what do we want to write down? What kind of mathematical model are we going to write down? And if you think about it, there's lots of things that you might want to write down about consciousness. It's a fairly complicated subject. So most of my colleagues are saying, let's start with matter or neurons and see what properties of matter could create consciousness. But I'm saying that whole thing is out. Space-time is doomed. That whole thing is out. We need to look at consciousness qua consciousness. In other words, not as something that arises in space and time, but perhaps as something that creates space and time as a data structure. So what do we want? And here, again, there's no hard and fast rule, but what you as a scientist have to do is to pick what you think are the minimal assumptions that are going to allow you to boot up a comprehensive theory. That is the trick. So what do I want? So what I chose to do was to have three things. I said that there are conscious experiences. Feeling of headache, the smell of garlic, experiencing the color red. Those are conscious. So that's the primitive of the theory. And the reason I want few primitives, why? Because those are the miracles of the theory, right? Primitives, the assumptions of the theory are the things you're not going to explain. Those are the things you assume.
And those experiences you particularly mean, there's a subjectiveness to them.
That's right.
It's the thing when people refer to the hard problem of consciousness, is it feels like something to look at the color red. Okay.
Exactly right. It feels like something to have a headache or to feel upset to your stomach. It feels like something. And so I'm going to grant that in this theory, there are experiences and they're fundamental in some sense. So conscious experience. So they're not derived from physics. They're not functional properties of particles. They are sui generis. They exist. Just like we assume space-time exists. I'm now saying space-time is just a data structure. It doesn't exist independent. Conscious experiences.
Sorry to interrupt once again, but should we be focusing in your thinking on humans alone? Or is there something about in relation to other kinds of organisms that have a sufficiently high level of complexity, or even or is there some kind of generalization of the panpsychist idea that all consciousness permeates all matter outside of the usual definition of what matter is inside space-time?
So it's beyond human consciousness. Human consciousness, from my point of view, would be one of a countless variety of consciousnesses. And even within human consciousness, there's countless variety of consciousness within us, right? You have your left and right hemisphere. And apparently, if you split the corpus callosum, the personality of the left hemisphere and the religious beliefs of the left hemisphere can be very different from the right hemisphere. And their conscious experiences can be disjointed. One could have one conscious experience. They can play 20 questions. The left hemisphere can have an idea in its mind. The right hemisphere has to guess. And it might not get it. So even within you, there is more than just one consciousness. There's lots of consciousnesses. So the general theory of consciousness that I'm after is not just human consciousness. It's going to be just consciousness, and I presume human consciousness is a tiny drop in the bucket of the infinite variety of consciousnesses.
That said, I should clarify that the black hole of consciousness is the home cat. I'm pretty sure cats lack is the embodiment of evil and lack all capacity for consciousness or compassion. I just want to lay that out. But that's the theory I'm working. I don't have any good.
There's two basic
Alright, I'm
assumptions.
gonna keep it rolling
There comes
because I
some
might
kind of
get lucky and get some
causality.
lightning.
Is a chain of causality? Is there related dynamics?
I'm gonna end this
I'll say there's a
video.
probabilistic
Put a
relationship.
green filter on.
So I'm trying to be as
I'm gonna actually
non-specific
put this
to begin
filter
with
on.
and see where it leads me. So what I can write down are probability spaces. So a probability space which contains